Welcome to the session on tuples in Python. I am Dipen Loskar, and today in this session we will provide an in-depth exploration about a Python data structure called tuples. Tuple is one of the most fundamental and powerful data structures available in Python. In the previous lecture, we discussed the list data structure. We all know that a list is in Python allows us to store an ordered collection of items. List items are mutable and list can also store duplicate data items. Tuples are almost identical to list except for one key property, they are immutable. Meaning is that tuples item cannot be changed or modified after their creation. Tuple is the only built-in immutable data structure available in Python, and it is the topic of discussion in today's session. Here is an outline of the topics we will cover today. The lecture will begin with the definition of tuples, various characteristics of tuples, and different use cases of tuple data structure. After that, we will discuss how to create and initialize tuples. Then we will showcase the accessing and slicing tuple items. Next, various methods and operations of tuples will be discussed. At the end, we will discuss the benefits of tuple data structure. Let us begin today's session. Definition of tuple. Like list, a tuple is also a built-in data structure. A tuple contains a sequence of data items, and the value of data items cannot be modified or changed once tuple is created. A tuple can contain elements of different data types, including integers, floats, strings, lists, and even other tuples. Tuples can also contain duplicate data elements. So, we can define a tuple as an ordered and immutable collection of elements that can contain items of various data types. Now, let us discuss the characteristics of the tuples. Tuples have many important characteristics. Let us discuss them. Tuples are immutable, which means once a tuple is created, after that we cannot change the content of the tuple. Elements of tuples are always ordered, means elements in a tuple are kept in the order of their insertion. Another important characteristics of tuple is that, like list data structure, a tuple can also store duplicate items, that is, items with the same values. Finally, like list, a tuple can also store mixed data items, that is, various data types such as integer, float, string, and list. We can also store a data items in a tuple. Now, let us discuss some important use cases of the tuple in Python programming. Use cases of tuples. The first use cases of tuples is storing fixed data. Tuple stores fixed data items. So tuples are ideal for storing data that do not require any changes throughout the program. Second use case may be returning multiple values from a function, where tuples can also be used to return multiple values from a function. It means if a function returns multiple values at a time, we can store them using a tuple. Tuples can be also used as dictionary keys. The concept of dictionary data structure will be discussed in coming lectures. Another use case of tuple is to store multiple values, as because tuples provide packing and unpacking provisions of its data items, which allows to store multiple values at once. Finally, one of the most important use of tuples can be their uses for maintaining data integrity. This is because tuples cannot be modified or changed directly, which protect them from accidental modifications, and hence they are helpful for maintaining data integrity. Till now, we got an idea about what actually a tuple is, its characteristics, and various uses. Let us now learn how to create tuples. A tuple is created by placing all the elements inside a parenthesis separated by commas. There are many ways to create a tuple, such as create a tuple with parentheses. We can create a tuple without parentheses. We can create tuples with mixed data types. We can create single element tuples. We can also create tuples using tuple constructor, and we can also create empty tuples. Let us discuss how to create tuples with parentheses. A tuple can be created by placing a comma separated list of elements inside parentheses. For example, here number is a tuple created using parentheses. Let us demonstrate it. Here we are considering a tuple which name as numbers, and we have considered 6 elements 1, 2, 3, 4, 5 and 6, and we use parentheses to create the tuple. Let's print the values of the tuple using print function. Let's see the output, and we have seen that all the elements are printed. That means tuple is created using parentheses successfully. Let us discuss how to create tuples without parentheses. A tuple can also be created by placing a comma separated list of elements only. Let us execute this example. Now we see how to create tuples without using any parentheses. We are considering the same tuple numbers with the same elements, but here we are not using any parentheses. Now we try to print the values using the print function, and here is the output. We have seen that same tuple is created without using parentheses. A tuple can contain elements of any data type. So, tuple can also be created to contain mixed data type items. Let us execute this example. Let us consider a tuple. Name is mixed tuple to contain, say, a number, a string, and a floating point number, and say a list. So different data items are present with different types. So let's print this tuple. So let's see the output. So we have seen that tuple is created with mixed data items. A tuple containing a single element can be created by placing a comma after the element. This type of tuple is called as a singleton tuple. For example, here single element is a tuple containing item hello. We see a comma is placed after the element hello. We can check the variable type using the type function available in Python. It should be noted that if comma is not included, then Python doesn't store the value as a tuple. Let us demonstrate this example. So let's check the type of the single element. Since we have placed the comma, so you have seen that the created object is a tuple. Now we know that if we omit the comma after the data item, so it's no more a tuple class. So let's see, and here we are omitting the comma and check the type of the single element that is being created here. So the output shows that it is no more a tuple, it's a string type. A tuple can also be created using a constructor called tuple constructor. For example, here number is a tuple created using the tuple constructor. We can create tuple using tuple constructor. So say the tuple name is numbers, and here we are using tuple constructor and pass the list as its parameters. Here the list elements are 1 2 3 4 5 and 6. Now let's print the values of the tuple numbers. So here is the output. So tuple is created using tuple constructor. The list containing elements from 1 to 6 is passed as an argument to the tuple constructor. An empty tuple is a tuple that contains no elements. We can create empty tuples either by empty parentheses or by using the tuple constructor. An empty tuple always has a length of 0. The length of a tuple can be checked using len function. Let us demonstrate this example. We can create empty tuples using both parentheses and using tuple constructor also. Here let the tuple name is empty tuple and try to create using parentheses. So let's print the empty tuple and see the output. So if seen, then there is no more element in the tuple. Let's try to create the empty tuple using tuple constructor. Here we are using tuple constructor and there is no parameter inside the tuple constructor, and see the output by printing the value of the tuple. Here it is empty tuple. So we have seen that tuple element is 0, that means no more elements are there. Now let us check the length of the empty tuple. We know that length of the empty tuple is always 0. Let's check by using the len function. So it returns 0, that means length of the empty tuple is always 0. Tuples can be initialized in multiple ways. We have already discussed initialization of tuples with and without parentheses at the time of creating the tuples. Tuples can also be initialized using other additional methods such as using nested tuples and initializing using a list. Let us first discuss tuple initializing using nested tuples. A tuple can be initialized to create other tuples as its elements. In such cases, it is called a nested tuple. Here we see the initialization of nested tuple called nested tuple consisting of two tuples, one containing items 2, 3 and other tuple containing items as 4, 5 and 6. Let us demonstrate this example. So here is the output. So we have seen that nested tuples can be created containing other tuple elements. A tuple can also be initialized using a list, and for this method we need the help of the tuple constructor. In the example, we see initializing the number tuple using a list called number list, and a tuple constructor is used to initialize the tuple. Here the list contain elements 10, 20, 30, 40 and 50 respectively. Let us demonstrate this example. So let's just create it. So let us create a tuple and the name is numbers tuple. So for this we have to use the tuple constructor, and we convert the created list into tuple by using the tuple constructor. Let's print the numbers tuple object, and here is the output. Once tuple is created, we can access the elements or items of the tuple like a list. There are two main ways to access the elements, and they are indexing and slicing. Let us discuss the indexing method first. In tuples, every element is assigned a position or an index associated to it. So, the elements of a tuple can be accessed by using their respective index number. The index operator is used to access an element in a tuple. In Python, two types of indexings are used, and they are positive indexing and negative indexing. Let us first discuss the positive indexing method to access the tuple items. In positive indexing method, elements of a tuples are accessed from the beginning. The index number in positive indexing starts from 0, and the following elements are at +1 and so on. The maximum index value in case of positive indexing will be n-1, where n is the number of total elements in the tuple. Let us demonstrate how to use positive indexing. Say here the tuple name is numbers and it contains 6 elements, 1, 2, 3, 4, 5 and 6. So let's print the values of the tuple numbers. So we have seen that tuple is successfully created. Now let's try to access the element present at index 2. So it is 3. We have seen that. So it should be return 3. So hence successfully returned the element 3. Let's try to access the element present at index 5. So we have seen that index 5 contains the element 6. Let's see the output. Yes, 6 is returned. Now what will happen if we put the index value out of bound? So in this considered tuple we have seen that the maximum index is 5. Let's try to access the element at index 6. So see, so the output is showing that index error. So tuple index out of range. So we cannot access elements out of range. Now let us discuss the negative indexing approach to access tuples. In case of negative indexing, elements can be accessed from the end, and here the index starts from -1. This means the last element will be present at index -1. The previous to the last element will be present at index -2, and this will be continued till the first element is reached. Let us demonstrate the use of negative indexing. Let us try to access tuple elements using negative indexing. Here we are considering the same tuple numbers containing 6 elements, 1, 2, 3, 4, 5 and 6. Let's print the tuple to see whether it is successfully created or not. Yes, it is successfully created. Now let us try to access the element 5. So we know that element 5 is present at the second position, that means index -2 from the last. So let's see. Yes, 5 is successfully accessed. Now let us try to access the element 2, which is present at the index -5. So let's see. Yes, 2 is returned. So hence we can use negative indexing to access tuple elements. Now let us see how to slice tuple elements. Slicing method of tuples allows to access the elements of a tuple within a given range. Range values can be given positive or negative. The syntax for slicing is shown in the screen. The start and stop value indicates the beginning and ending values of the range, and they are separated by using a slicing operator called colon. The third parameter in the tuple slicing is the step, which specifies what steps to be taken in slicing a tuple. The slicing method of tuples outputs a new tuple from an existing one. It should be noted that the item in the last position in slicing is excluded from indexing the tuple items. The step value is optional and it basically indicates the interval between the indices. The beginning or the ending value of the range can also be omitted, that is, they are optional. Negative range values can also be used to access elements within a range. Let us try to demonstrate tuple slicing. So here we are considering the tuple vowel consisting of 6 elements A, E, I, O, and U. So let's print the tuple to check whether it is successfully created or not. Yes, it is successfully created. Now let us try to access elements starting from index 1 to index 5. So yes, output is coming, all the elements within the range is printed. Now let us try another range starting from index 1 to index 4. Let's see the output. Yes, 3 elements are printed. Now in case of tuple slicing, we can omit the beginning and ending index. Let us try to access elements omitting the beginning index and try to access elements up to index 5. So here we are omitting beginning index and we try to access elements up to index 4 and see the output is coming. So now we omit the end index and try to access elements starting from index 1. So it will print all the elements starting from index 1. Yes, we can also access or slice tuples using negative indexing as below. Let us consider another tuple letters consisting of 6 elements, say A, B, C, X, Y, and Z. Let's print the tuple to check whether it is created successfully or not. Yes, it is created successfully. Now let's try to access all the elements from starting index 0 to index 5 at the interval 2. So we have to provide step value as 2. So beginning index is 0 and the index would be 5 and step is 2. So yes, output is coming. So we can also access tuple by providing negative indexing. So let's try to access elements from starting index -5 to index -2. Here is the output. Once tuple is created, we can apply various operations on the created tuples. In this tutorial, we discussed the tuple operations like updating a tuple, adding a new element to a tuple, removing an element from a tuple, reassign a tuple variable, deleting a tuple, unpacking a tuple, and join operation in tuples. Let us discuss them in detail. Let us discuss how to update a tuple. As discussed earlier, tuples are immutable and cannot be changed once they are created. But there are several situations when we need tuple to be modified. Tuples cannot be updated straight away. To overcome this problem, a tuple can be converted first into a list which is mutable and then finally converted back to the required modified tuple. Let us demonstrate an example to show how to update a tuple. Let us see how we can update a tuple. We know that tuple cannot be updated, but we can update the tuple by converting it into list. So here we are considering a tuple number containing 6 elements, 1, 2, 3, 4, 5, and 6. Let us print this tuple. Yes, the tuple contains the 6 elements. Now say we want to modify the first element. So to do this, we have to convert this tuple into a list. So here we are considering the converted list as num list. So let's print the list. So the num list is created successfully. Now once the list is there, we can update any value. So let us see the data item present at index 0 of this list. So it is 1 definitely. Now say we want to modify the value 1 as 10 in this list. So to do this, we have to change the value at index 0 as 10, and once it is created, we can see that the list is modified. And let's see the output of this modified list. Now to update the tuple, we have to convert this list and save this list at the same name as numbers, and for this we have to use the tuple constructor and pass the argument as numList. So let us print the modified tuple numbers. Yes, we have seen that the first element is changed from 1 to 10. So tuple is updated. Like updating a tuple, we can add new elements to a tuple. For this, a tuple should be converted to a list first to allow appending a new element to the tuple. After the conversion of the tuple to a list, new elements can be added applying append operation available in list. Let us demonstrate an example to show how to add elements into a tuple. Similar to previous example, we can also add elements into a tuple. Here we are considering the same tuple as considered earlier. So to add elements into the tuple, we have to convert into a list. Let us check the created tuple by printing it. So let us print the tuple. Yes, the tuple is successfully created. Now to add elements into the tuple, we have to convert it into the list first. So here we convert the numbers using list function, and let's see whether the list is created successfully or not. So let us print the list. Yes, the list is successfully created. Now once it is successfully created, we can add element to the list because list is mutable, and we can use append function to add element. Say 20 is added to the list, and let us print the list. Yes, the list is created. Now we have to convert this list into the original tuple. So for this we have to use tuple constructor and pass the numList as argument. Now let's print the tuple numbers. Yes, 20 is added successfully. Like adding an element, we can also remove elements from a tuple. For this, we also should convert the tuple into a list first to allow removing an existing element from the tuple. After the conversion of the tuple to a list, we can remove the specified element from the tuple by applying remove function. Let us demonstrate an example to see this. The same tuple name numbers is used here containing 6 elements. So removal operation of elements from a tuple is similar to adding elements in a tuple. So we have to convert it into the list. Here the num list. So number list is converted using the list constructor. Let's print the converted list, num list. So we have seen that tuple is converted in the list. Now once list is there, we can remove any elements from this list. So let us remove the element 2 by using remove function. Let's print the num list after removal of element 2. Yes, element 2 is removed. Now we have to convert it into a tuple by using tuple constructor. So we convert the num list into tuple and save with the same name and see the output by printing the tuple. Yes, we have seen that element is removed from the tuple. Let us see how to reassign a tuple variable. We know that the elements of a tuple cannot be sensed directly. However, we can reassign the different values to the same tuple. Let us demonstrate this with an example. Let us see how we can reassign a tuple with different values. So say the tuple is numbers as considered earlier containing 6 elements, and let us print the tuple items. Yes, the tuple is successfully created. Now we cannot modify the individual items, but we can reassign this tuple with different values. Say we reassign values as 1 to hello world and another value say 5.67. Now let's check the output after reassigning. Hence the tuple is successfully reassigned with different values. Now let us see how to delete a tuple. As we know that tuples are immutable, so it's not possible to remove the tuples elements directly. However, we can delete the tuple completely using a keyword del. Demonstrate this example. We can delete tuples using del function. Let us demonstrate it. So here we are considering the same tuple containing 6 elements. Let print the tuple. Here it is shown that it is successfully created. Now let us delete the tuple using the del. So we have to write the command and now try to print the tuple. Because it is permanently deleted, so it should be show error. Yes, the system shows that tuple is not defined, so tuple is successfully deleted. Let us discuss the tuple unpacking operation. Tuple unpacking is a powerful feature in Python that allows us to parse or assign the values of a tuple element to individual variables in a single line. Unpacking of tuples allows access to the values of the tuple as individual variables without having to access them via indexing. This feature makes working with tuples more convenient and simpler. To store tuple items in individual variables, multiple variables are to be used on the left of the assignment operator. There are different methods available for unpacking the values of the tuples. Some of them are basic tuple unpacking method. We can unpack tuple items using asterisk, unpack tuple items using underscore, tuple unpacking in function return, etc. Let us discuss these methods. We can directly unpack a tuple into individual variables by matching the number of elements in the tuple with the number of variables. An example is shown here. Here, number of variables present on the left of the assignment operator is equal to the number of items in the respective tuples as shown in the example. Let us demonstrate it. Let us consider the basic tuple unpacking method, and here we are considering the same tuple numbers containing 6 elements. So in case of basic tuple unpacking, we have to use the same number of elements present in the tuple. So here we need 6 elements. Here it is A, B, C, D, E, and F, and we put the tuple name, and let us print value A. So the value A is unpacked as the first element. So second element is unpacked. So similarly the other elements. So let's print all the elements. So we have seen that all the elements are unpacked into 6 different variables. Elements of a tuple can be unpacked using asterisk. This method allows us to extract multiple elements of a tuple into a list while unpacking. See a demonstration of this method. Let us see how to unpack tuples using asterisk. So here we are considering the same tuple containing 6 elements. In case of tuple unpacking using asterisk, the excess elements are returned as a list. So here we are using two variables. One is with asterisk, which is B, and other is without asterisk. Now let us print the value A. We have seen that a single value is printed. Now let us print the value B. So we have seen that the list is returned. That means when you use the operator asterisk, a whole list is unpacked. Now how to unpack tuple items using underscore. In case of unpacking tuple items using underscore, we can ignore certain elements at the time of unpacking by placing the underscore as a placeholder. Let us demonstrate this example. So let us demonstrate how to unpack tuple items using underscore. So here we are considering the same tuple numbers containing 6 elements. So unpacking using the underscore, using as a placeholders, we can omit some values. Let us skip the second 4 elements of the list. So let us print the values. So we have seen that 4 values are printed. The second and fourth element are skipped. Now let us discuss how we can unpack tuples in function return. If a function returns its value as a tuple, then the returned values can be unpacked directly into multiple variables. In the example shown here, we unpack 4 values that are returned from the function get student info. Let us demonstrate this example. Tuple unpacking in function return. For this, let us define a function get student info. Say this function returns 4 different values. Say the return values are Bobby, then say another value 67, say name say Python, then other value say pass. Now we have to come out of this function. Let's all the value returned by this function are stored in 4 different values, say name, marks, course, and result. So the values returned by the particular function is stored in these 4 variables. Let's check the output. So let us print the name value. Yes, it Bob is returned. That means Bob is unpacked to the name variable. Let us print marks. Yes. So we have seen how to unpack tuples in function return. Another important operation is the tuple join operations. Tuple can be combined to form new tuples. The process of combining tuples is known as joining tuple operations. There are several ways available to join tuples. Two popular ways for joining tuples are joining tuples by using plus operator, which is known as concatenation, and another method is joining tuples by multiplication, that is using star operator. Let us demonstrate with examples. Say tuple is considered with name tuple names containing say three elements, Jan, Fev and Fev. So we know that we can join tuples using plus operator and multiplication operator. Let us print the created tuple months. So we have seen that tuple is successfully created with three elements. Let us consider another tuple, say tuple days. It contains say two elements, Sunday and another element, Monday. Let us print it. So the output shows that the tuple creation is successful. Let us join these two tuples into another tuple as tuple result. So to do this, we have to use the plus operator between tuple months and tuple days. That means these two tuples are joined into the result tuple. Let's check whether it is successful or yes or not. So output shows that elements are joined. That means new tuple is formed by joining these tuples. Now let us check tuple joining using multiplication operator. That means using repetition. So let us consider the tuple months containing January and February elements, and we consider another tuple, say tuple results, where we join the tuple months multiplied by 3. That means the tuple result will have elements 3 times as the tuple months. Let's check the output. Yes, tuple joining is successful using multiplication. Tuples in Python facilitates many built-in methods. These methods can be used for fulfilling various requirements. Here we discuss some popular tuple methods such as count, index, len, max, min, and sum. The count method counts the number of occurrences of a specified element in a tuple. The index method returns the first element of a specific value in the tuple. The len method can be used to return the total number of elements present in a tuple. The max method is used to find the largest element present in a tuple. Similarly, the min method is used to find the smallest element present in a tuple. The sum method can be used to find the sum of all the elements present in a tuple. Let us demonstrate these methods with examples. Let us apply the count method first. For this, we declare a tuple consisting of elements 1, 5, 5, 2, 4, 5, 4, 6, 3, and 5. So let us print the tuple. Now try to implement count method. So count method basically returns the number of occurrences of an element. Let us try to apply count method for element 5. So in this tuple we see that tuple contains 4 occurrences of element 5. So let us return the count value for item 5. Yes, 4 is returned. That means element occurred 4 times. Now try to apply index method. in this tuple. So apply the index for the element 4. So index 4 returns basically the first occurrence index of the element. So let us check the index for the element 4. Yes, it returns 4. Though the element 4 occurs in two positions, one is at index 4 and another is at index 6, but it returns the first occurrence. Now let us demonstrate len function, that is the len method for the tuple. Len method basically returns the length of the tuple, that means number of elements in the tuple. Here we see that there are 10 elements in the tuple. Let's see, and then print the length of the tuple. Yes, it returns 10, that means it's correctly returning. Now let us demonstrate the use of max method. So for this we use a variable maxval to store the maximum value. So max method basically stores or returns the largest item present in the tuple. Let's print the max value. Yes, it returns 6. 6 is the largest value in the tuple. Now let us implement min method. So min method basically returns smallest item present in the tuple. So we have seen that 1 is the smallest element present. So we use here minval to store the minimum value. Let us print it. Yes, it returns 1 because 1 is the minimum value. Finally, let us see the use of sum method. Sum method returns the sum total of all the items present in the tuple. So let us use a variable total to store the sum of this tuple. Yes, it returns the total value, which is 40 in this case. Till now, we have discussed almost all the topics related to tuples. Lastly, let us discuss the benefits of using tuples. Tuple has many benefits. Let us discuss a few of them. First benefit is related to data integrity and safety. Tuples offer data integrity and safety due to its immutability feature. Tuples save data values from accidental modifications that may happen due to unintended bugs or errors. Another benefit of tuples is its performance efficiency. Tuples are fixed size and their contents are also fixed. This makes tuple more performance efficient, especially working with large data sets, because Python can efficiently manage fixed size data. Finally, tuples are hashable due to their immutable property, and hence they can be used as keys in dictionaries. Dictionaries is also one type of built-in data structure available in Python. A detailed discussion on dictionaries data structure will be covered in upcoming lecture. This lecture session have provided a comprehensive understanding of tuple data structure used in Python programming. To sum up, in this tutorial, we have discussed the definition, characteristics, and various use cases of tuples data structure. We have learned about the creation, initialization, and accessing elements of the tuples. We have also discussed various tuple operations and methods with suitable examples. At the end of this lecture session, we have also discussed the various benefits of using tuples. Let's take a moment to go over a few quick multiple choice questions related to the topics covered in this tutorial. Thank you for joining this session. If you have any queries or feedback, feel free to reach out. Thank you.